As we are dealing with discontinuous functions, sometimes it's possible to remove a discontinuity by extending a function and creating a new value within the function. So at the end of this lesson, you'll be able to extend a function if possible to remove a discontinuity. All right, let's look at the following function. Notice we have three discontinuities happening in this, and we're going to see, can we remove those discontinuities? Right, number one says what value should be assigned to f of 3 to make the extended function continuous at x equals 2. So if we look, and that should be x equals 3. So if we look at x equals 3, and we look at what could I put in there. So if we didn't have that there and we just plugged the hole, what would my new value of f be so that that is now continuous? And at x equals 3, if we reassigned a value of 2, so if we put f of 3 equals 2, it then would be a continuous function there. Right, number 2, is it possible to extend the function to be continuous at x equals 6? If so, what value should the extended function have there? If not, why not? So if we look at x equals 6, once again, there's just a hole there. It's a removable discontinuity, so I can plug that hole by just giving a value at 6. So if I give the value 4 at x equals 6, I am able to plug that function and make it continuous. So if I let f of 6 equals 4, I have now extended the function to make it continuous at x equals 6. Notice both of those happened at removable discontinuities. Right, number 3, is it possible to extend the function to be continuous at x equals 0? If so, what value should the extended function have? If not, why not? So I'm going to look up at x equals 0. Notice we have something else going on here. If I just filled in that hole with a different point, notice it's still discontinuous. So that would not be a removable discontinuity there. That's going to be a non-removable discontinuity, or we could actually call it a jump. So is it possible to extend the function? No, it is not. And when it said if not, why not, the discontinuity is non-removable. We can't just plug it in with a value. And I could say there is a jump discontinuity there if I wanted to go a little bit farther. At x equals 0. Right, so now hopefully you will be able to determine if you can extend a function to make it continuous at certain points.